Hi, my name is David Staples. I teach a variety of different IT and project management courses, and today I'm going to teach you one of the easiest ways that I know to actually divide up a network into different subnets. So let's start off in Microsoft Excel here and go through a little bit about what makes up an IP address. So in an IPv4 IP address, these are 32-bit numbers. So typically we see these as something like 255.255.255.0, for instance, for a subnet mask. And this is the primary thing that we're going to be looking at here is our subnet mask. So in this type of a network, we basically have 256 usable IP addresses, or 256 IP addresses in this particular network. So two of those, of course, are going to be used for our network ID and for our broadcast ID, which means that we have 254 hosts in that network. So let's go ahead and use the example of that 255.255.255.0 to start off with, and maybe we can work into some of these other types of networks or some of these larger networks here later on. So when we take a range of 0 to 255, we know that we have 256 numbers, right? And IP addresses being 32 bits, that means we have 8 bits in each of what we call an octet. So there's 8 bits in this 255, 8 bits in this 255, 8 bits in this 255, and 8 bits in this. Currently it's a 0, but if we were to turn that into a binary number, that 0 is basically going to be 8 zeros. If we're looking at the number 255, then of course it's going to be all ones. So we essentially, in binary, start counting from our right-hand side. So we count from 1, 2, 4, 8, 16, 32, 64, and 128. So each of these numbers in this placeholder represent one of these numbers down here in decimal form. So let's just go ahead and turn all these back to zeros for now. So this number right here in binary, just 8 zeros, is the number 0. And this number right here in binary is the number 255. So working with this 255.255.255.0 subnet mask, essentially we need to divide this network perhaps into say 4 different networks. So we know that when we take this number here, 128 and 64, that comes up to 192. So we'll turn all the rest of these to zeros, and we come up with a subnet mask of 255.255.255.192. So essentially now what we can do is we can say, we look at the placeholder, the very last placeholder going from the left. We say, okay, we know that there are 64 total IP addresses in the network for 255.255.255.192. So we can say 256 divided by 64, we know equals what? That is 4. 64 plus 64 is 128. 128 plus 128 is 256. So if we use this particular subnet mask, we know that, assuming that this is the last octet, that this is going to create 4 networks with 64 IP addresses in each network, which of course we now have a network ID and a broadcast ID for each of those. So we know that we have 62 usable hosts. And that's really all there is to it when it comes to dividing up a network, creating these custom subnet masks. So let's go ahead and take another example here. Let's go ahead and add in a 1 here. So 128 and 64 is 192. If we add 32, that becomes 224. So this subnet mask then becomes 255.255.255.224. So now, I'll give you a moment to kind of think through this on your own. How many networks would this create, and how many IP addresses and how many usable IP addresses or hosts can we use out of that particular network? So if we used a subnet mask of 255.255.255.224, how many IP addresses total would be in that particular network? How many networks does that create out of a particular range? So maybe we're using the 192.168.0. whatever range here. And how many usable hosts are going to be in each of those networks? So if you said that we're going to have 32 total IP addresses in each of these networks, You would be correct. And of course, we know that with 32 total IP addresses, the very first one is our network ID, the very last one is our broadcast ID, which means that we have 30 possible hosts that we can assign IP addresses to out of that network. So let's just go ahead and put in a real world example here. So we'll say 192.168.0.0, and we're going to use the subnet mask of 255.255.255. Let's go with 240 here. Go ahead and erase this information here. So let's say that we're using this 192.168.0.0 network, a subnet mask of 255.255.255.240. So what numbers do we have to add up down here to come up with 240? So we know that 128 and 64 is 192. If we add 32 to it, it becomes 224. And then of course if we add 16 to that, we get 240. So our subnet mask in binary is going to be 4 ones and 4 zeros. So when we look at it in binary, we know that that 240 subnet mask means we're going to have 16 IP addresses in each of these networks. And then of course if we take 256 divided by 16, so equals 256 divided by 16, we come up with 16 total networks out of that range as well. So let's go ahead and kind of run through the range of what networks this would create. So this would be 192.168.0.0 would be the first IP address. So let's just go ahead and set up our cells here. So what would be the last IP address in that network? We know it's going to be 192.168.0 because we're still using a subnet mask that is masking off the first 3 octets here. So 192.168.0. If you said 15, you'd be absolutely correct. So let's just go ahead and repeat this a few times here. So the next network is going to be 192.168.0. What's the first number in it? And if you said 16, that would be absolutely correct. And the last IP address in this network is going to be 192.168.0. That would be 31, right? So next we have 192.168.0. We're going to go with 32 this time. And we'll just go ahead and come on down this left-hand side first so we can just kind of count by 16. So we'll say 192.168.0. That should be 48. Then we'll have 192.168.0. Let's see, add 16 to that is 58, so 64. 192.168.0.80. And I'll just stop right there. So we know that this one's going to be 192.168.0.47. 192.168.0.63. 192.168.0.79. And this one's going to be 192.168.0.95. So these are the first 6 different networks we've created out of the 192.168.0.0 network, which originally had 256 IP addresses in that network when we were using the subnet mask of 255.255.255.0. But since we needed to divide that up into smaller networks, remember, we've created a total of possible 16 networks with a total of 16 IP addresses per network, which means when we have 16 total IP addresses, the first one is going to be our network ID, the last one is going to be our broadcast address, and so that leaves us with 14 usable hosts in each of these networks. And again, just as an example, these are the first 6 networks that we create. And we could go ahead and keep on coming down here and list out all 16 networks, but hopefully you've got the idea here. So if you've got any questions regarding this subnetting, feel free to send me an email anytime. My email address is david@chiefquiz.com, and I'll be happy to answer any questions that you've got. Let me see if I can make that a little bit bigger here, at chiefquiz.com, and we'll turn that back into some larger text here. So again, I'll be happy to answer any questions you've got and help you out with your subnetting and your networking. So look forward to seeing you in a future video. Have a great day.